Welcome to AI Frontiers, where we explore revolutionary research reshaping human-AI language interaction. Today we're diving into 17 groundbreaking papers from October 24, 2025, covering computational linguistics breakthroughs that span bias detection, multilingual AI, and emotional understanding. From emergency dispatch systems to fair language models, we're examining research that builds bridges between human language and machine logic. Picture this scenario. It's 3 a.m., and someone calls 911 in a panic because their loved one has collapsed. The dispatcher needs to extract crucial information from a distressed caller, provide life-saving guidance, and coordinate emergency response while the clock ticks. Now imagine if an AI system could simulate these high-stakes medical conversations with perfect accuracy, helping train dispatchers for real emergencies. This isn't science fiction anymore. It's happening right now in research laboratories around the world. We're witnessing a language revolution where human communication meets machine intelligence in unprecedented ways. Today's research showcases AI systems that can detect their own hallucinations, models that understand emotions across all cultures, and fair language processing systems designed for every human language on Earth. These discoveries aren't just academic exercises. They're the foundations upon which tomorrow's AI systems will be built, fundamentally changing how machines understand and interact with human language. Computational linguistics serves as the master translator between two worlds that have historically struggled to communicate effectively. On the human side, we have metaphors, emotions, and rich cultural contexts. On the machine side, we find algorithms, probabilities, and mathematical functions. This field is like studying birds to build better airplanes. By teaching machines to understand and generate human language, researchers often discover new insights about communication itself. Every time you ask Siri a question or use Google Translate, you're experiencing decades of computational linguistics research in action. Our first major theme focuses on fighting what researchers call the warped mirror effect in AI systems. Just like Carnival funhouse mirrors create predictable distortions, AI systems can systematically distort their understanding of different groups based on biased training data. Atij Mahesh and colleagues have revealed fundamental limitations in preference learning approaches, showing that current bias-fixing methods are inadequate for handling complex constraints. The challenge isn't just identifying bias. It's developing new approaches that go beyond simply ranking good versus bad outputs. The second theme addresses breaking down language barriers through multilingual AI development. Currently, we face a digital language divide where AI systems work exceptionally well in English but struggle with other languages. Shane Longpre and colleagues conducted systematic studies involving hundreds of languages, working to build fair AI systems for Cherokee, Swahili, and Mandarin speakers alike. Their research tackles the curse of multilinguality, where adding more languages typically degrades performance for each individual language, through sophisticated optimization techniques. Our third theme involves peering inside the black box of AI systems to understand how they actually work. It's like having a brilliant friend who gives amazing advice but can never explain their reasoning process. Benjamin Reichman and colleagues are decoding how AI systems process emotions, developing mechanistic interpretability techniques that reveal the internal mechanisms behind AI responses. This understanding is crucial for building safer, more reliable systems that we can trust in critical applications. One of our most striking findings reveals a preference learning paradox that challenges core assumptions about AI training. While supervised fine-tuning achieves a remarkable 99.87% success rate on complex bias constraints, direct preference optimization, despite being theoretically sophisticated and widely popular, manages only 4.53% success. The issue is fundamental. Preference signals encode rankings rather than logical requirements. It's like trying to teach someone to bake a cake by showing examples of good and bad cakes, rather than providing the actual recipe with specific measurements and steps. Today's featured paper, Compositional Bias Control in Large Language Models, by Atij Mahesh and colleagues, challenges fundamental assumptions about ethical AI training. The research tests AI systems' ability to balance traditionally masculine descriptors like ambitious and decisive with feminine descriptors like supportive and nurturing when describing various occupations. This seemingly simple test reveals catastrophic failures in preference optimization methods, bridging theoretical computer science with urgent social equity concerns that affect millions of AI users daily. The compositional constraint challenge demonstrates why current bias control methods fail at handling complex requirements. The task requires AI systems to include both ambitious and supportive characteristics in job descriptions, a simple request that reveals profound limitations in training approaches. Preference learning methods teach systems to rank outputs rather than satisfy specific constraints. For complex requirements involving multiple simultaneous conditions, explicit positive supervision through supervised fine-tuning proves far more effective than preference-based approaches. The implications of this research extend far beyond bias control into AI safety, instruction, following, and multi-step reasoning capabilities. These findings question prevailing wisdom in the AI alignment field, suggesting that as we develop more sophisticated systems capable of complex ethical reasoning, we may need to fundamentally rethink our training methodologies. The research opens new directions for handling complex constraint satisfaction, while providing immediate practical guidance for building more reliable AI systems that serve millions of users daily. Looking toward future horizons, we're approaching AI systems that truly understand human communication in all its complexity. Imagine AI assistants that adapt their emotional tone to match your needs, while maintaining perfect factual accuracy, where language barriers disappear through fair multilingual systems, and where we can prevent harmful outputs by understanding the internal mechanisms that generate responses. The research we've explored today is laying the foundation for human-AI collaboration in life-critical scenarios, combining machine consistency with human empathy and contextual understanding. This revolution in computational linguistics is just beginning, and you're witnessing its foundational moments. We've discovered that ethical training methods need fundamental rethinking, that AI systems possess universal emotional patterns enabling better human-computer interaction, and that multilingual AI can democratize technology access globally. These aren't merely academic discoveries. They're building blocks for tomorrow's AI systems that will be more fair, more capable, and more aligned with human values and needs across all communities worldwide. Before we conclude, let me share how this research summary was created. AI synthesis was performed using Claude Sonnet 4 from Anthropic, with TTS synthesis powered by DeepGram technology and image generation through OpenAI systems. This content underwent human expert review, though we acknowledge potential oversights may exist. All original research references are provided for your verification, ensuring you can dive deeper into these fascinating discoveries and form your own informed conclusions about their implications. Thank you for joining us on AI Frontiers as we explore these computational linguistics breakthroughs. Subscribe for weekly updates on cutting-edge research. Dive deeper into the papers through our provided references and share your insights with our growing community. Help shape AI's future through informed engagement as we continue exploring tomorrow's technology today. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses archive-preprintserver.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by archive-preprintserver.org.